Today we will talk about how would the world look without water. It goes without saying that the human race wouldn't last very long in a world without water. The same can be said of all animals and plants, as well, since H2O constitutes one of the building blocks necessary for life to thrive. But what would happen to the planet itself? With no oceans, rivers, or lakes, it would certainly look altogether different. But in what other ways would it change? Here are a few possible consequences if all of the water on our great green Earth vanished overnight. Changing faces. For starters, it wouldn't be quite so green for very long. With no water supply, all vegetation would soon die out, and the world would resemble a brownish dot, rather than a green and blue one. Clouds would cease to formulate and precipitation would stop as a necessary consequence, meaning that the weather would be dictated almost entirely by wind patterns. Indeed, other than fluctuations in wind force, our climate would resemble one endless summer, but not the shorts and t-shirt holiday kind, the fletched, meltingly hot kind. The oceans of the world constitute the biggest deposits of carbon, and recently it was found that Arctic melting released nitrous oxides, NO2, and sulfur dioxide, SO2, as well. With these sinks gone, the greenhouse gases would have a field day and temperatures would spiral out of control. Of course, the absence of vegetation would contribute to the problem, since plants would not be around to convert carbon dioxide, CO2, into oxygen, thus exacerbating the situation. Today's climate change issues would seem small fry in comparison. Fewer volcanoes, more mountains. Perhaps surprisingly, however, the volcanic activity would decrease in the face of a watered Earth. Volcanoes, supervolcanoes, and their eruptions are actually caused by tectonic plates colliding with each other and running over one another. Something which is generally caused by the weight of oceans pushing one plate beneath another. What's more, once the volcano has been formed, water also plays an integral role in its volatility. The liquid inside the Earth's crust at high temperatures and high pressures becomes magma, resulting in eruptions like the one at Vesuvius, which did for poor old Pompeii. Therefore, with no ocean to weigh plates down and no water to power eruptions, we'd be left with a series of incredibly high mountain ridges anytime two tectonic plates collided. Of course, such a process would take millennia to occur, but the end result would be a desert-like, barren globe populated by spiky ridges and gulfing chasms. Let there be life. Remarkably, however, this wouldn't mean the end of all life on Earth. Evolution has a funny way of persevering even in the most difficult of circumstances. And over the millennia, certain microbes known as extremophiles have evolved to be capable of living without water. Instead, extremophiles harvest their nutrients from carbon monoxide, CO, meaning they can thrive even in sizzlingly hot or acidic environments without water or sunlight. Some of them inhabit the Earth's crust, while others are effectively dormant in a state of suspended animation inside gigantic subterranean crystals. So while humanity and the animal kingdom would most certainly snuff it, life would still find a way. How Earth would actually look without water. The drawing above shows blue spheres representing relative amounts of Earth's water in comparison to the size of the Earth. Are you surprised that these water spheres look so small? They are only small in relation to the size of the Earth. This image attempts to show three dimensions, so each sphere represents volume. The volume of the largest sphere, representing all the water on, in, and above the Earth, would be about 332,500,000 cubic miles, Mi3, or 1,386,000,000 cubic kilometers, Chem3, and be about 860 miles, about 1,385 kilometers in diameter. The smaller sphere over Kentucky represents Earth's liquid freshwater and groundwater, swamp water, rivers, and lakes. The volume of this sphere would be about 2,551,000 cubic miles, 10,633,450 cubic kilometers, and form a sphere of about 169.5 miles, 272.8 kilometers in diameter. Yes, all of this water is fresh water, which we all need every day, but much of it is deep in the ground, unavailable to humans. Did you notice the tiny bubble over Atlanta, Georgia? That one represents fresh water in all the lakes and rivers on the planet. Most of the water people and life on Earth need every day comes from these surface water sources. The volume of this sphere is about 22,339 cubic miles, 93,113 cubic kilometers. The diameter of this sphere is about 34.9 miles, 56.2 kilometers. Yes, Lake Michigan looks way bigger than this sphere, but you have to try to imagine a bubble almost 35 miles high, whereas the average depth of Lake Michigan is less than 300 feet, 91 meters. Ignore these water spheres, and you'll see what Earth actually would look like without water. In fact, the oceans are too shallow compared to Earth's diameter. But no, the Earth isn't as smooth as a cue ball either. Earth's water vs. Europa's water. Scientists' consensus is that a layer of liquid water exists beneath Europa's surface. It is estimated that the outer crust of solid ice is approximately 10 to 30 kilometers, 6 to 19 mi, thick, including a ductile warm ice layer, which could mean that the liquid ocean underneath may be about 100 kilometers, 60 miles, deep. This leads to a volume of Europa's oceans of 3x1018 and 3, between 2 or 3 times the volume of Earth's oceans. Europa, Jupiter U, diameter 3,122 kilometers / 1,940 miles, is the smallest of the 4 Galilean moons orbiting Jupiter and the 6th closest to the planet. It has a smooth and bright surface, with a layer of water surrounding the mantle of the planet, thought to be 100 kilometers thick. The smooth surface includes a layer of ice, while the bottom of the ice is theorized to be liquid water. The apparent youth and smoothness of the surface have led to the hypothesis that a water ocean exists beneath it, which could conceivably serve as an abode for extraterrestrial life. Heat energy from tidal flexing ensures that the ocean remains liquid and drives geological activity. Life may exist in Europa's under-ice ocean, perhaps subsisting in an environment similar to Earth's deep ocean hydrothermal vents or Antarctica's Lake Vostok. Life in such an ocean could possibly be similar to microbial life on Earth in the deep ocean. Misha Vallejo, a documentary photographer based in Ecuador, explored the area around Lake Pupo in Bolivia as the water started disappearing in 2016. The lake, which is the second largest in Bolivia and located in the Altiplano Mountains, had shrunk in the past, but never to the same extent. The Bolivian government blamed El Niño and climate change, while others said that water mismanagement may have also played a role. What do you think of our video? Let me know in the comment section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.